Welcome to the second screencast on subroutines. I'm still a little under the weather, so I apologize in advance. We're going to talk about parameters, or passing parameters in, and actually getting return values out of subroutines, or functions, as we'll talk about later. So parameters is a way, or a mechanism, for passing information into the subroutines. It allows us to do the task on different sets of data so the task can, average different numbers or whatever the task is, but it allows us to pass information into the subroutine so they can do a task. They are part of the interface. The type of each parameter, the number of parameters, there's a 2, 7, and 19, and the order, excuse me, of the parameters. So if you say, I have an int, a double, and a float, that's different than a float, an int, and a double. So the order, their type, it's part of the interface, and you have to supply them in the order that they are defined in the interface. It allows us to get values from, or to pass values from outside the subroutine into the subroutine, because inside the subroutine is where the work is actually done. We just call the subroutines when we want the work to be done. So this allows us to actually change the results of the task by passing in different information. So here's an example, our classic 3n plus 1 problem. So we're going to print out the 3n sequence. We have a parameter called starting value. It's an int. And then, excuse me, that's going to be the starting value that the outside world is going to pass us. And then so what we do is we assign that value to n. We keep track of a count, print out this nice thing, we're starting at n, which is starting value. We then print out n, and then we loop, deciding whether if the n is odd. If it's odd, we multiply it by 3 and add 1. If it's even, we divide it by 2, increment the count. Eventually we'll get to n being 1, and we're done. And then we print out the number of times we went through the loop. So this is the subroutine that prints out the value. Notice that we don't know what the starting value is inside. We just know that somewhere outside in the world, someone's going to give us a starting value. And it's got to be an int. It's not going to be a double. It's not going to be a string. It's going to be an int when they call this sequence. Excuse me. So we don't know as we're working, but we don't care. They're going to give us an int. We're going to run the algorithm. We're going to output the value, and so the parameter is the int starting value. So it's the type and the name of the parameter. So there's a concept of formal and actual parameters. The formal parameters are in the description or the definition of the subroutine. So that's the int n, double x, Boolean test are the formal parameters that we pass in or define them. The actual values are supplied by the code that calls the subroutine. So in this case, the actual value of n, and when we run do task in this time, it's 17. The double x will be assigned to the square root of z plus 1. And the Boolean test will be assigned to the evaluation of z greater than or equal to 10. So those are the actual parameters that are passed in when do task is called with this particular sequence. So the formal parameters are n, x, and test. The actual values are set when the subroutine is called. And notice their type is correct. They have to be typed. N is an int, so 17 is an int. Math square root returns a double, so that matches x. And z greater than or equal to 10 is a Boolean value, so that matches test. Otherwise, we can't call do task if we don't match the types and the order of the parameters. So we couldn't say math square root, comma 17, comma z is greater than or equal to 10. It must be the same order, the right type. Overloading is when we have subroutines with the same name but different parameters. For example, we've seen this already. We have println that takes an int, println that takes a char, println that takes double, a boolean, a string, and nothing, no parameters at all. Now this allows the implementer of the subroutine to deal with different specific implementations of how they do the task. It could be that it is in the implementation, it's different to print a character than it is an integer. You have to do some work to print it out, convert it to Unicode, whatever. Same thing with all these other types. We can't have the different signatures only being different by their return type. Notice all the print lines have different parameters. So when it's called, Java can determine which one was called. Is it a Boolean? Well, there would be a Boolean expression there. So I call print line Boolean. Excuse me. Is it a double? I call print line double. Is there none there? I call it print line with nothing. So Java can decide which one I need to call. If the only difference is the return type, Java can't decide which getLN to call, because an int you can assign an int into a double, so it's just not legal to have in Java, the only difference being the return type. So the signature return type, signatures don't include the return type. It's only the name of the method, the subroutine, and the list of parameters. And they need to be unique. You cannot have getLN with no parameters declared twice. That's illegal. You have to use unique signatures. So you can't do that. You must have different parameters. Now, why would we want to overload them? Well, why have the same name? Why not say println int, println char? Well, doesn't it make it more sense to say, I just want to print line this thing, and I don't want to have to remember, is it int or capital int or integer or whatever. Just it's print line. That's what I'm trying to do. I'm printing out this thing, and I want a new line at the end of it. So that's why we use overloading, because you would have to call a different subroutine name based upon the parameters you're giving it. So by using overloading, it simplifies the user or the developer to say, I know what I want to do, I know the name of the subroutine, I can call it. So here's some examples of how to come up with a subroutine, writing subroutines. There's several examples in the text, they're very good. So we have the task of writing a subroutine to compute and print out all the divisors of a given positive integer. So we have our step one, fill out the subroutine signature. I have the signature here, which is up above. So we have the modifiers, the return type, the name, the parameter list, and then the statements. So what are the modifiers for a subroutine to compute and print out all the divisors? So far we've talked about static. We're going to continue to use static subroutines. And should this be public or should this be private? I decided public because I want other people to be able to call this subroutine and have it print out all the divisors for the integer. So what's the return type? Does this subroutine, does the description look like it needs to return anything? No, so I put void, pick the name, print divisors, and then the parameter list. I have a given positive integer, so I have an int n. Now, is n have to be positive? No, because nothing here is saying it has to be an int. It could be a negative number. We'll have to handle that potentially in the actual statements. So now we want to continue on with our problem solving. So we want to replace the statements with the tasks. Step 2, fill in the steps to solve the task. So for each possible divisor d in the range from 1 to n, if d evenly divides n, then print d. Because if d evenly divides into n, then we have a divisor of n. So the for each is a for loop from 1 to n. Oh, divisor, we print that out. for loop for 1 to n. I missed a close paren on my for loop. Oops. Now, if d evenly divides into n, well, how do we do that? So it's n mod d equals 0. So if n mod d equals 0, then we print out d. And finish the for loop, and then this subroutine, if I remembered to put in the close parentheses right after the d++, it would print out all the divisors of n from 1 to n. Now, if n is negative, what happens? Let's think about this a little bit. D starts at 1, n is negative. Is d ever going to be less than n? No, it can't be. So we don't execute anything. So it says the divisors of negative, whatever value n is, are, and it prints out nothing because there are no divisors of a negative number. Now maybe we would want to check that and maybe do something different later on. So example 2, go through the same steps. I'll write a private subroutine named print row. It should have a parameter of ch of type char and a parameter n of type int. The subroutine should print out a line of n copies of the character ch. So fill out the signature. Well, they told us that it's a private subroutine, so it's going to be private static because we're using static. Again, does the description say we need to return anything? No, so the return type is void. They told us what the name is, it's print row, and they told us what parameters there is. So the first one is ch of type char, and then we have n of type int, right? Type first, name of the parameter, type name, so char, ch, int, n. And then we have the statements. The subroutine should print out a line of n copies of ch, so print ch n times, and it says a line, so we want to print these side by side, and then we want a new line. So how do we print ch n times? For I equals 1, I is less than or equal to n. You could also say for I equals 0, I is less than n, right? If we go 0, it's much more of a Java programming style. If we say equals 1, that's much more counting style. But if we do that, then we need to stop at n. So I is less than or equal to n, I plus plus. We system out print line, or print, not print line, excuse me, the character. So we're going to print the character n times. And then we need to print out a new line, system out that print line. So this subroutine will print a row of ch's, or not ch's, the character n times, and then hit a new line. So we've defined the subroutine, we filled in the definition, and then we filled in the body. Example number 3, write a subroutine that takes a string as a parameter. For each character in the string, print out a line of 25 copies of that character. Excuse me. Step 1, fill out the subroutine signature. So, excuse me, it doesn't say it's private. So, excuse me. So we might as well make it public. That's private. I made it private. We can make it public or private. Doesn't matter, doesn't say. So this particular instance, I said private. What's the return type? It again doesn't say what we're doing, so might as well be void. What's the name? We're printing copies of a string, so print rows from string. And it takes a parameter list, takes a string parameter, so string, and then what's the name of the parameter? I called it str, which is abbreviation for string. Could have called it s. You can't call it string because string is a keyword. You could call it string, I guess, but since string is a keyword, it's not good to use a variable name that is a keyword. And so now we need to do the work. So we go to step 2. We've got the signature done. Now we need to do step 2, fill out the subroutine, do the work. So we want to, for each character in the string, we print a row with n equals 25. So we're going to use the subroutine that we defined in the previous example to actually do the work of printing out the 25 characters. So how do we do the for each character in string? We take a for loop, I goes from 0, I goes to the length of the string, I plus plus. And again, because we're in Java, we're using zero-based indexing, so we want to print the row with n equals 25, but for each character. So we use the print row subroutine we defined previously. String char at I returns the character at the ith position in the string str. And how many times were we supposed to print that character? It says 25, so we pass in the 25. So this will loop over the string and print out each character in the string 25. The print row will put a new line, so we'll have each string 25 times down to the end, and we have solved the problem. So that's an example of writing a subroutine that uses another subroutine we've already written to help solve the problem. Now this code is a lot simpler than having to solve the print row problem here in the print rows from a string. Because if I want to print row elsewhere, that functionality is actually useful here, so I can just call that subroutine. It does the task. I can call the subroutine from anywhere inside the class because it was private, but I can call it because it's private. I'm inside the class, I can use it. So that functionality lets me solve this problem a lot easier than having to re-implement the print row subroutine here in the for loop. So another way of doing parameters, excuse me, not another way of doing parameters, but we can pass in arrays as a parameter instead of trying to say, oh, I want to pass in 7 items or 7 ints. I will pass in int number 1, int number 2, int number 3. Why don't I pass in an array of ints into the subroutine? And so it's passed in as a single parameter. Now, inside the subroutine, I can access all the items in that array by referring to the array. So I have an array of ints called list. I can loop over all the items in that. So I can go for int I equals 0, I is less than list.length, which tells me how long it is, and I increment I, and I print out list sub I. So I have access to every item in the list. So this is a very convenient way of passing in a lot of the same type. I create an array of that, I can pass it in. The subroutine gets it as a single parameter. I don't have some long list of parameters. It's just a list, an array. I can access the items in the array. I can do stuff with the array. I can deal with it. It's a very powerful way of passing in things. So you can use arrays as parameters, and it's a very convenient way of doing that, of passing in multiple items. And that leads us to the concept of command line arguments. And if you remember back our programming algorithm, you read the problem, you create the Java file, you insert the boilerplate, and the boilerplate, remember, public static void main takes an array of strings called args. It doesn't have to be called args, but we often write args. Excuse me. And then we fill in the pseudocode comments. We refine until we can replace. What is args? Well, it's the command line arguments. It's what can be passed into the program from the outside. So what's outside the program? Well, if we're running the program from the command line, so example, we write Java, my program, which is the class, right? And then we say 1, 2, or 3. The string 1, the string 2, and the string 3 are additional information that is passed into the program as an array of 3 strings, the string 1, the string 2, and the string 3. So that's what args will be. Args will be a string array with 3 values. In the 0th position will be 1, in the first position there'll be 2, and the second position there'll be 3. This is often used for how users can pass in like file names to programs. So like you're writing a program that needs to read in a text file and do something to the text file. Well, how do you get that text file's name into the program? It's very easy to pass it in as a command line argument. That way, the program can run without having to have any additional user interaction. You just run the program with the name of the file and it will execute. Very powerful way of doing things, and that's why we name that string args, because it is the command line arguments. So what is the subroutine contract? It's a contract between the developer of the subroutine and people who use the subroutine. So the subroutine signature is the syntax, right? You've got to supply, the name's got to be right, and the number of parameters has to be correct, and the order of the parameters has to be correct, and that's the syntax. If you fail to provide an int to print divisors, then you can't call it because it's a compiler or it's a syntax bug. But what happens if the parameter passed in, because there's no limits on the parameter n here, we talked about previously when we do the print divisors, if n is negative, that's not correct because that's not a semantically correct statement. You can't look at the divisors of a negative number. So how do we handle that in the code? Well, there's several ways to deal with it. One is, and it's probably one of the better ones, is if n does not match our semantic requirements, that n must be positive, and it can't be 0. So if n is less than 1, we can throw a new illegal argument exception, which we talked about a couple times ago, about how exceptions are situations that are outside the normal, that are sort of errors. Like you called this, I want a positive integer, but you gave me a 0 or negative integer, so I'm going to throw an illegal argument exception. The rest of my subroutine doesn't run, the exception gets thrown, the person calling print divisors needs to handle the exception or eventually stop the Java program. So the way to handle semantic errors, that if they give you a valid typed parameter, an int, but there's something wrong with the int, maybe you said I want an odd value, you would check to see that the value is odd. If it's not odd, you would throw the exception. That's a way of enforcing the semantics of your subroutine. Again, subroutine says, here's the syntax that you use, and there are some requirements or potential requirements on the parameters you give. You can't just give me any int, I need a positive int. So you check for that, throw a new illegal argument exception. So last time I talked about static member variables, right? Global variables, they're declared outside the subroutines. They're available to all of the subroutines, but they may even not, if they're static, they're only available to static subroutines. If they are non-static, then they're available to all non-static subroutines. We have local, which we talked about before, which are any variables declared inside the subroutine. They're only available to subroutines. And now we add this new sort of variable concept of the parameters that we're passing in to the subroutine. The value is actually set, the actual value is set outside the subroutine, and we can treat them as local variables within the subroutine. The parameter name is a local, you can consider a local variable of the type of the parameter, and you can use it in the code inside your subroutine. So we've added this third type of variable, which basically is a parameter. So the last thing to talk about now is return values. Subroutines to return a value are called functions. Functions can only return a specified type of return, because in Java you need to say what is the type of the thing returning. In Java they have a special statement called return, and then you have an expression, and when Java sees the return expression, it will evaluate the expression and return that value as the result of the subroutine or the function call. The type of the expression must match the return type declared in the function definition. So here's an example. We define a static method, static function, returns a double called Pythagoras, takes a double x, takes a double y, it returns the square root of x squared plus y squared. So the return statement here is we do the math, and then we return the result of the value. So if we call Pythagoras with 12 and 5, basically what happens is we replace, because it's just simple, we're going to do the math of 12 times 12 plus 5 plus 5 times 5, then we take the square root, which is 13.0. We add that to 17, which is 30.0, and we're done. Now, we can put return statements in multiple places in our subroutine, and when they get executed, that's the value that's returned. So here's an example of next n for our 3n plus 1 example. If n is odd, we want to return 3 times the current value plus 1. Else, if it's even, we return 1 divided by 2. So you have two different return statements. Only one of them will be executed. It's the one that happens to hit. That can be slightly confusing. Some people prefer to have only one return statement at the end. Most people, or most more experienced programmers, don't have a problem with that. They'll put the return statements where the work is actually done, and instead of having to create local variables to return. Remember the return value. You have to ensure that they're all set by the time you get to the end. I find it easier if I just return when I know the answer. And that's basically the idea of parameters and return values for subroutines. Thank you.